Assalamualaikum and good day everyone. So today we look at chapter 10.0 mechanical wave. For 10.1 we have properties of wave. So let's look what is wave. Wave is defined as the propagation of the disturbance that carries the energy and momentum away from the source of this disturbance. And mechanical wave is defined as the disturbance that travels through particle of the medium to transfer energy. For mechanical wave, we have two waves, which is progressive wave, and also stationary wave. And for progressive wave, it is divided into two, which is transverse wave and longitudinal wave. Alright, so we can look at this one. The particle oscillate around their equilibrium position but do not travel. Okay, so ni kita punya tangan saya kata. Alright, so ni kita ada string and we move the string ups and down, okay, perpendicular to the direction of motion of the wave. So to the right is the direction of motion of the wave. So kalau kita vibrate the particle ups and down, and then the particle ups and down, and direction of the wave particle is to the right, so we can say that it is 90 degrees. Direction of propagation of wave and direction of vibration of particle is 90 degrees. So yang ni kita panggil sebagai transverse wave. Nanti kita tengok lagi. Okay, all mechanical waves require some source of disturbance, medium that can be disturbed, and a mechanism to transfer the disturbance from one point to the next point along the medium. Okay, so kita tengok dulu progressive wave. It has a definite speed called the speed of propagation or wave speed. So kita V is equal to F lambda. Direction of the wave speed is always the same as the direction of the wave propagation. Okay, so kat sini wave speed lah kita ada V equal to F lambda, and the direction is always the same as the direction of the wave propagation. There are two types of progressive wave. What is that? That is transverse wave and also longitudinal wave. Transverse wave, as I said before, is the direction of vibration of particle is perpendicular to the direction of the wave propagation. Okay, so kat sini kita ada direction of particle is up and down, and the direction of wave propagation is to the right. So the direction of the wave propagation, direction of particle vibration is 90 degrees. So kita panggil dia sebagai transverse wave. Okay, kita panggil dia sebagai transverse wave. Satu lagi kita ada longitudinal wave. Longitudinal wave is the direction of vibration particle is parallel to the direction of the wave propagation. So kita gerakkan kita punya particle to the right and to the left, and the direction of propagation of wave is to the right. Okay, to the right. So yang kita nampak kat sini, so dia akan nampak dia sebagai parallel. Direction of vibration of particle and direction of the wave propagation is parallel each other. Alright, so for the outcome 10.1a, we have to define wavelength and wave number. Wavelength, the symbol is lambda, and the wave number is k. So kita tengok kat sini, figure shows the periodic sinusoidal waveform. So we have crest or peak, and we also have trough. What is crest? Crest is the highest displacement. We also call as amplitude. Trough is the lowest maximum displacement. Okay, kita panggil dia sebagai trough. So ini pun dia adalah amplitude, maximum displacement, tapi di bahagian lowest. Okay, alright. So di mana the distance between crest to crest is lambda. Distance between crest, maximum displacement, to maximum displacement here is lambda, and also the lambda is also we can kira ni daripada amplitude trough ni sehingga trough. Ini juga adalah lambda. Okay, so this is some important quantities to describe periodic sinusoidal wave. Showing table, we have displacement. What is displacement? The distance moved by a particle from equilibrium at every point along the wave. And then we have amplitude, which is the maximum displacement from the equilibrium position to the crest or trough of the wave motion. So the symbol is A. Ini adalah Y maximum, which is amplitude. And then we have frequency. Okay, we have frequency is the number of complete cycle that pass in a point per second. So frequency is equal to 1 over T. The symbol is, the unit is hertz or per second. And then we have period is the time taken for the particle to complete one cycle of its oscillation, or the time for the wave to travel one wavelength. Itu adalah period, di mana period ni sama dengan 1 over F. So unit dia adalah second. Then we have the angular frequency. With the angular frequency, the formula is omega equal to 2 pi f, or we can have 2 pi over t. The unit is radian per second. Then we have wavelength is the distance between two successive crests, or distance between two successive troughs. Okay. Okay, distance between two successive elliptical points in the wave, itu adalah kita punya one wavelength or one lambda. Then we have wave number, the number of wave exists in 1 meter. We have K is equal to 2 pi over lambda, the formula. Then we have the phase angle that shows the relationship between the vibration of particle to another. Okay. Alright, so here you have to solve problems related to the equation of progressive wave. It shows that the progressive is the profile moving to the right. So when moving to the right, the particle, or the general equation is y x t equal to a sin omega t minus kx. Okay, so kita tengok satu-satu. Okay, x, y is distance moved particle from its equilibrium position. Distance particle move from origin. Okay, a is the amplitude of the wave. Ini adalah kita punya wave number. K equal to 2 pi over lambda. Kita ada angular velocity. This is our angular velocity. Angular velocity 2 pi over t. Okay, and then we have time. Alright, so kat sini kita tengok the direction of wave propagation. There are two direction, where for the equation y x equal to a sin omega t minus kx. Okay, minus kx shows that the wave propagates to the right, and then satu lagi kita ada plus. Okay, the wave propagates to the left. Okay, so negative just means the direction of wave propagation. Boleh juga kita tulis y x t equal to a sin kx minus omega t. This omega bukan kepunyaan, this minus bukan kepunyaan omega. This minus just shows that the wave propagates to the right. Okay, satu lagi kita ada y x t equal to a sin kx plus omega t. So this plus just shows that the wave propagates to the left. So we can have the equation either this one, omega t minus kx, or a sin kx minus omega t. Alright, so the negative here just shows that the wave propagates to the right, ataupun the wave propagate from left to right. Okay, the wave propagates from left to right. Satu lagi kat sini, kalau negatif, positif kat sini, okay, a sin omega t plus kx, or we can have a sin kx plus omega t. So we can say that the wave is propagate from right to left. Itu one lah. Okay, kita salah satu saja kita guna. Kita tak boleh gunakan plus ataupun minus simultaneously. Okay, let's discuss about the use particle vibration velocity and the wave propagation velocity. We have two, particle vibration velocity and also the wave propagation velocity. Particle vibration velocity is the velocity particle which oscillate about equilibrium position yang kita belajar dalam simple harmonic motion. Okay, kita belajar dalam simple harmonic motion. Kita ada v dy over dt, or we can have v equal to a omega t plus minus kx, ataupun v equal to omega a squared minus y squared. Okay, this one is in function of time, this one in function of y. Okay, so kita ada lagi the wave propagation velocity. Okay, the wave velocity is the velocity in which wave crest or part of waveform move forward. Okay, we have v is equal to distance over time. So distance here is lambda and time is period, t is period. Okay, so we have v is equal to f lambda. So remember that the wave velocity v is constant, but the velocity of particle vy is varies with time. Okay, kita tengok pula 10.1d, discuss the graph of displacement versus time and displacement versus distance. Okay, so pada sini, for the graph of displacement versus x. Okay, for example, we consider this equation y is equal to a sin omega t plus kx. Okay, for the particle when t is equal to 0. Okay, kita tengok what happen. Y equal to a sin omega t plus kx. So bila t kosong, kita ada sin kx saja. Okay, sin kx saja. So kita nak lukis graf. Okay, kita ada y versus x. Okay, kita nak tengok when x kosong. Okay, kat sini apa jadi pada y? Okay, apa jadi pada y? So tekan calculator. Okay, press your calculator, make sure in radian mode. Okay, kita tekan calculator. Y equal to a sin 0. Okay, sin 0, make sure in radian mode. Sin 0 you all dapat berapa? Sin 0 is 0. Okay, so dia akan mula daripada sini, mula daripada atas ni. Okay, mula daripada kosong. So kita buat graf, dan ini adalah kita punya okay, so bila y versus x, kita ada one wavelength. Okay, one wavelength. Okay, kita tengok pula satu lagi. For the particle at t equal to 0.25. Okay, so kita ada y equal to a omega t plus kx. Okay, so y equal to a sin omega is 2 pi over t plus kx. Okay, so kita ada sin 2 pi over t, kita ganti-ganti 2/5t plus dengan kx. Okay, we cancel of t, so we have y equal to a sin 0.5 pi plus kx. Alright, so kita nak buat dia punya graph. So when x equal to 0, so kita ada y versus x. Okay, kita nak tengok when x equal to 0 what happen. So when x equal to 0, kita ada masuk kat sini. Okay, kita x0 kan. Okay, x0. So calculator in radian mode. Okay, so bila kita tekan calculator in radian mode, kita akan dapat sin 0.5 pi. Okay, so dia adalah 1. So bila 1, amplitude darab dengan 1 kat sini. Okay, so kat sini kan ada a sin 0.5 pi. Sebabnya x sudah kosong, so tekan, kita akan dapat amplitude. So bila amplitude, dia akan ada di sini. Kita start dengan sini. Okay, kita start dengan tak ada. Kita akan start dengan maksimum. So your graph should be like this. So this one is your lambda. Okay. Okay. So seterusnya pula, okay, kita ambil yang ni. Kita nak sketch graph of y versus t. Okay, the graph shows the displacement of any one particle in the wave at any particular distance from the origin. Okay, so here is the formula. So this negative shows that the direction of the propagation of wave is from from right. Negative is from right to right, left to right, from left to right. Okay, so when particle at x equal to 0, so y equal to a sin omega t minus kx. So y equal to a sin omega t sahaja. Okay, so untuk graph sin omega t, y kita ada t. So when t kosong, kat sini kita nak tengok when t kosong, so kita buat y equal to a sin kosong. Okay, so bila a sin kosong, bila sin kosong, okay, sin 0, kita akan dapat 0 juga. So the graph will be like this. So ini adalah kita punya period. Okay. Okay, so kita tengok pula when x equal to 0.5 lambda. So we have y equal to a sin omega t minus kx. A sin omega t minus k. K is 2 pi over lambda, 2 pi lambda. So cancel off the lambda. So what equal to a sin omega t minus 0.5 pi. Okay, so when t equal to 0, when t equal to 0, kita kali. Kenapa kita nak buat t equal to 0? Sebab kita nak tahu dekat t kat sini ni berapa y kita. Okay, so kita tekan calculator. So kita ada y equal to a sin 0 minus 0.5 pi. Make sure your calculator in radian mode. Okay, so kat sini kita akan dapat y equal to negative amplitude. Okay, make sure in radian mode. Okay, so kita akan start ke sini and negative amplitude. So this is our graph, this is amplitude. So kat sini kita panggilkan dia, ini adalah period sebagai intensity. Kalau against T, kita ada period. Kalau against X, kita ada lambda. So now we continue our lesson on exercise number 1. A progressive wave is described by y equal to 2 sin 2 pi bracket of t over 0.4 plus x over t, where x and y are in centimeters and t second. Determine the following from this wave. Okay, so kita samakan the equation. Y equal to a sin omega t plus kx. So kat sini kita ada y 2 sin omega is 2 pi over 0.4 ot plus dengan 2 pi x over 8t. So here you can have your amplitude is 2 cm, your omega is 2 pi over 0.4, your k is 2 pi over 8t. Okay, so your amplitude here is 2 cm, your wavelength. So macam mana dapatkan wavelength? We can have wavelength from k, which is the wave number. K equal to 2 pi over lambda, so 2 pi over 8t. So here you can have your lambda is equal to 80 centimeter. And then you can find your frequency. Your frequency is you can find from your omega, where omega equal to 2 pi f. Your omega is 2 pi over 0.40. So your frequency is 2.5 Hertz. So then you can find the speed, where speed v is equal to f lambda. So v, your f is 2.5 and your lambda is 80 times 10 power of -2. So you have your v is 2 meter per second, or in centimeter we have 200 centimeter per second. Alright, for B, for the wave shown in A, determine the maximum value of dy over dt at x equal to 0. So we know v is equal to dy over dt. So we can have a omega cos omega t plus kx. So v is equal to 2, your omega is 2 pi over 0.40 cos 2 pi over 0.4 ot plus 2 pi over 80x. So your v is 10 pi cos 2 pi over 0.4 ot. So for v maximum, we can have 10 pi centimeter per second, where cos 2 pi over 0.4 ot is equal to 1. So then we can have question number 3. Okay, number 2 tak perlu buat lah. Alright, so number 3, a progressive wave is represented by the equation yxt 5 sin 2 pi t over pi over 2x. So kita samakan dengan basic equation, sin omega t minus kx. This minus just shows that the wave is traveling to the right. So y is equal to 5 sin 2 pi t minus pi over 2x. So di sini your omega is 2 pi and your k is pi over 2. Where y and x are in centimeters and t is in second. So here you have to determine the amplitude. So the amplitude is 5 centimeter. The angular frequency omega you can have equal to the angular frequency omega equal to 2 pi radian per second. The wavelength omega equal to 2 pi over lambda, omega equal to 2 pi. Okay, omega is equal to silap kat sini, silap 2 pi lambda. Okay, you have to find the wavelength. You have k equal to 2 pi over lambda. Your k is equal to pi over 2. Okay, so your lambda equal to 4 centimeter. To find the period, so period we can have from omega 2 pi over t. Your omega is equal to 2 pi radian per second, then your t is equal to 1 second. For the frequency also 1 hertz, because t equal to 1 over f, f equal to 1 over t. And then the last one, you have to find the wave speed. The wave speed v is equal to f lambda. Your f is 1 and your lambda is 4, so v is 4 centimeter per second. And the direction of the motion, so we can have from here where the direction of motion is to the right, or from left to right, the direction of wave propagation. Okay, this negative shows the direction of wave propagation either to the left or to the right. Okay, B. Sketch the displacement against distance. Graph the progressive wave above of the range 0 x to lambda at t equal to 0 second. Okay, so for the equation y x t equal to a sine omega t minus kx from the above equation, y x t equal to 5 sine 2 pi t minus pi over 2x. Okay, so mula-mula kita dapatkan dulu dia punya lambda, sebab kita nak plot graph of displacement versus distance. Okay, kita dapatkan dia punya lambda. Okay, so kita ada y versus x. Okay, kita dapatkan dulu lambda. Macam mana cara lambda? We can have lambda from our k. Okay, so we know that k equal to 2 pi over lambda and k equal to pi over 2. So lambda pi equal to 4 pi. So lambda equal to 4 centimeter. Okay, 4 centimeter. So here you can plot the graph of 4 centimeter. So separuh daripada 4 is 2. Okay, half from 2 is 1, and then here we have 3. Okay, so because here we have you have to plot 2 lambda, so this one is 5, 6, 7, 8. Okay, so for 2 lambda. So here you write a table. Okay, make a table for x and y. This one is 4, 0, 1, 2, 3, 4. Okay, so kita cari dulu untuk x equal to 0. Okay, so for this one, okay, dia kata apa? At time t equal to 0. At time t equal to 0, so your equation will be like this. Y x 0 equal to 5 sine 0 minus pi over 2x. Okay, so then you have to gantikan. I buat kat sini. Okay, I buat kat sini. Okay, kita gantikan y. Okay, kalau x kosong, so tekan calculator. Negative pi over 2 x yang kosong lah. Okay, so bila you tekan calculator, so then you have your y is equal to 0. Make sure your calculator in radian mode. Okay, so kita plot kat sini. Okay, then kita gantikan pula x equal to 1. So y 1, 0, 5 sine negative pi over 2 sini. So then when you insert into your calculator, you akan dapat y equal to negative 5. Okay, so bila dapat negative 5, so kita plot kat sini negative 5. This one is 5, so negative 5 should be here lah. Okay, so kita dah dapat dah dia punya pattern. Kita tak perlu nak cari banyak-banyak. kita dah dapat dah dia punya pattern. So kita lukis saja sinusoidal graph. This one. Okay, so ini adalah 5 amplitude, negative 5 amplitude. So this is the graph for displacement against distance for the range of 0 to 2 pi. Itu lambda. Okay. Then we repeat our question B, but for time equal to 0.5t. So you have y x t equal to 5 sine 2 pi t minus pi over 2x. Okay, so kita gantikan y x t equal to 5 sine 2 pi, your t is 0.25 t minus pi over 2x. So remember that this t, okay, kita tengok t dekat sini is equal to 1 second. Okay, t equal to 1 second. So you have y x t equal to sine 0.5 pi minus pi over 2x, because t is equal to 1. Okay, so di sini kita buat sekali lagi table. Okay, buat table. So x, y, 0, 1, 2, 3, 4. Versus x. So this one is 4, 8, 2, 1, 3, 6, 7. So kita gantikan equation kita. Okay, so y 0 t equal to 5 sine 0.5 pi minus 0. Okay, so bila tekan calculator, make sure your calculator in radian mode. Okay, you akan nampak kat sini y is equal to 5. Okay, so y x equal to 0, y 5 kat sini. Ini negative 5. So bila 5 kat sini, kita terus dah nampak dah dia punya pattern. Okay, macam ni pattern dia. Okay, this one is the pattern sinusoidal graph. Kalau nak gantikan sekali lagi pun boleh. Okay, kita ada y1 t equal to 5 sine 0.5 pi minus pi over 2. Okay, so y kat sini you akan dapat 0. Boleh cuba nanti buat sendiri. Okay, seterusnya untuk D, sketch the displacement against time. Tadi displacement against distance. This one is displacement against time for the particle x equal to 0 at the range of 0, t and 2t. Okay, again we use the same equation. Y x t equal to a sine omega t minus kx. Y x t equal to 5 sine 2 pi t minus pi over 2x. So remember here your omega is 2 pi and your k is pi over 2. Okay, so then here for x equal to 0, so y 0 t 5 sine 2 pi t. Okay, so kita nak dapatkan dulu dia punya period. Sebab kita nak plot graph of y versus t. Okay, y versus t, the one sinusoidal or complete oscillation is our period. So this one is omega. So we can have your omega is 2 pi over t equal to 2 pi. So your period equal to 1 second. So here is 1 second, here is 2 second. Separuh daripada 1 is 0.5. So this one you have 0.25 and 0.75. One you have 1.25. We have 1.5 and 1.75. Okay, so do your table. Okay, the table here, just a small table I plot for you. You can have your t and your y. So this one is 0, 0.25. Tak perlu buat banyak pun tak apa, sebab kita dah dapat pattern nanti. Okay, so saya gantikan dulu. Okay, y 0, 0 equal to 5 sin 0. Okay, so 5 sin 0, press your calculator, make sure your calculator in radian mode, so you can have your y equal to 0. Okay, your y equal to 0. So then kita gantikan pula y 0 is your t is 0.25. So 5 sin 2 pi, your t is 0.25. Okay, tekan calculator. 5 sin 2 pi 0.25. Okay, you akan nampak kat sini y equal to 5 cm. Okay, so kat sini kita boleh plot. Kita dah tahu dah dia punya pattern. So yeah, you can plot the graph. Okay, this is the pattern of the graph. This one is negative 5 and this one is 5. Okay, so this is the pattern of the graph of y versus t. And then seterusnya, for E, sketch the displacement against time graph for the particle at x equal to 1.5 lambda in a range of 0 to 2t. Okay, so again we use the same equation, sin omega t minus kx. So y equal to 5 sin 2 pi t minus pi over 2 x. So y equal to 5 sin pi t minus pi over 2. Your x is 1.5 lambda. Okay, kita cari dulu lambda kita. Berapa lambda kita? Lambda here is, so lambda, okay, your lambda is 4 cm. Your lambda is 4 cm. So y equal to 5 sin 2 pi t minus pi over 2, 1.5, 4 cm. You have 6 lah. Y 5 sin 2 pi t minus 6, so 3 pi. Okay, so again we plot the graph of y versus t. So here your t is 1 second, so I put here 2 second, 0.5, 1.5, 0.75, 1.25, 1.75. Okay, so kita buat table. Okay, draw table for t and y. 0 for second is 0.25, and then we have 0.5 and 0.75. Okay, so kita tengok. So kat sini kita ada YXT lupa nak letak kat sini tapi you buat sendiri nanti. YXT equal to 5 sin 2 pi t minus 3 pi. Okay, so kita gantikan t as 0 kita gantikan t equal to 0, so y 0 5 sin t is 0 minus 3 pi. So kita akan dapat kat sini y equal to 0. So ni 5, this one is negative 5. So y 0. Kita tekan calculator. 5 sin negative 3 pi. Okay, kita dapat 0. So 0. So satu lagi y 0 is 0.25 equal to 5 sin 2 pi t minus 3 pi. So kat sini 5 sin 2 pi, your t is 0.25 minus 3 pi. So your y is equal to negative 5 centimeter. Okay, tekan calculator ni dulu. Okay, tekan your calculator. This one is negative 5. Okay, so when 0.25 tu you akan dapat negative 5. So pattern kita dah nampak dah. Pattern macam ni. So when you can see your pattern here. Okay, kita tak perlu nak cari banyak-banyak. Kita buat je pattern sinusoidal wave. Okay, boleh. So tengok kat sini. Tengok kat sini penting untuk you tengok betul-betul. 0.25, so ni t you gantikan. Okay, so you tekan calculator, make sure your calculator in radian mode. Okay, cantikkan graf Okay, we go to number 4. A progressive wave is represented by the equation where y is in centimeter and t is second. Calculate the wave velocity, where you have to find your v. So you have the basic equation for this one is omega t minus kx. So your y is 20, sin your omega is 1/5 pi, t minus 1.8x. So here your amplitude is 20 centimeter, your omega is 1/5 pi, your k is 1.8. Okay, negative meaning that the wave is propagation to the right, from left to right. Okay, so calculate the wave velocity. So wave velocity, we know that v is equal to f lambda. So here you have to find your frequency first. So we can find frequency from our omega. 2 pi f equal to 1/5 pi. So pi, so 2f equal to 1/5. Frequency is 75 Hertz. Okay, 75 Hertz. Your lambda you can have from your k. Okay, your k equal to 2 pi over lambda. 1.8 equal to 2 pi over lambda. So your lambda is 2 pi over 1.8. So then your lambda is equal to 3.49 meters. Okay, 3.49. So your v will be 3.49. 261 61075 meter per second. Okay, wave velocity. Dia tanya wave velocity. Velocity is vector quantity, so you have to put the direction. The wave propagation is from left to right, or you can have to the right. Okay, seterusnya number 6. Number 5. Number 5, figure shows the displacement versus distance from the progressive wave, which propagates to the left with the speed of 20 cm per second. Determine the wave number and the frequency. Okay, for the wave number is k and the frequency is f. Okay, so here your amplitude is 6 cm, your v is 20 cm per second. Here is your lambda. Your lambda is 2 cm. So you have to find your k, which is the wave number, 2 by O lambda. So k, your lambda is 2. So then 2 times 10 power of negative 2. So then your k is 314.16 meter per meter. Or you can have 100 pi per meter. And then the frequency, v is equal to f lambda, so 20 negative 2 f lambda is 2 negative 2, so your frequency will be 10 Hz. Okay, finish A. Okay, write the expression for the displacement as the function of x and t for the wave above. So the basic equation is sine plus kx. Kenapa plus? Because here the progressive wave is propagate to the left. Okay, so kalau left, ingat kita punya equation kita ada plus. Plus meaning the wave is propagates to the left, or from right to left. Okay, so y equal to 6 sine 2 pi ft plus 2 pi over lambda x. Okay, 6 sine 2 pi ft 2 pi over 2 times 10 power of negative 2x. So y equal to 0.06 sine 20 pi t plus 100 pi x. Okay, this is plus. So it is where y is in meter, t is in seconds. Okay, good luck. We continue to 10.2 hari Isnin. Okay, bye.